Hello, this is the next video in a playlist that I'm calling Applied Multivariate Analysis, and we're in Chapter 11, part of this playlist that I'm calling Factor Analysis. And this is a brief introduction to factor analysis. And so factor analysis is basically a one-sample procedure, and we assume a random sample from size n. So each observation is a vector. We're collecting p different pieces of information on each observation, and it's from a homogeneous population with mean vector mu and covariance matrix sigma. Now, the goal of factor analysis is to reduce the redundancy among the variables by using a small number of factors. The basic assumption in the analysis is that the observed multivariate measurements are the representation of more underlying latent variables that are not observable. For example, these are the observed measurements, are grades of 5 subjects, so math, computer programming, social studies, history, English literature. And the thought is the latent factors are the capacity of logical thought and the capacity of literature. So math and computer programming are very analytical and logical. And so these two variables are just pieces of some underlying factor called capacity of logic. And the other 3 variables are just 3 variables of, that all fall into capacity of literature. So what we do is we'll take these 5 variables and represent them as 2 variables. And one is the logical thought and the other is capacity of literature. But how we do that, it's pretty unique in how this is all structured. So now let's suppose the correlation matrix has this form. Now notice variables 1 and 2 have high correlations amongst themselves and low correlation among the other 3 variables. And then variables 3, 4, and 5 have high correlation amongst themselves and low correlation with the other variables. And so it seems pretty intuitive that there's 2 underlying factors here called latent variables that give rise to variables 1 and 2. And then another factor that is representative of variables 3, 4, and 5. So we'll combine these into one factor and these 3 variables into another factor. And then we'll represent our data in that fashion. Now, it's often mistaken that factor analysis and principal components analysis are essentially the same thing. And their ideology is so different. Now, you can use principal components analysis to help develop the factors in factor analysis, but the objectives are different. So factor analysis and principal components analysis both pursue a simple structure and a set of variables, but they differ in many respects. So the principal components are defined as linear combinations of the observed variables, and each linear combination in principal components analysis is to represent the maximum variance in that direction, where in factor analysis, the observed variable is expressed as combinations of factors and these latent variables. Now, principal components analysis, we try to explain a large portion of the total variance of the variables, and in factor analysis, we seek to account for the covariances or correlations among the variables. Now, there's 2 broad categories of factor analysis. One's called exploratory factor analysis and the other is confirmatory factor analysis. Now, an exploratory factor analysis most often used to explore multivariate data to identify possible latent structures. The number of latent factors is not determined before the analysis, and that's the goal of exploratory analysis. And then in confirmatory factor analysis, the researcher hypothesizes the number of factors and the specific nature of the latent structure of the data, and then tests the hypotheses that have been formulated. Now, this confirmatory factor analysis uses more traditional statistical notation of the model formulation, parameter estimation, model evaluation, and statistical inference, etc. Now, the one big caveat is that there will be some data sets that factor analysis models does not provide a satisfactory fit. And sometimes A few easily interpretable factors emerge, but other data sets, neither the number of factors nor the interpretation is clear. And it really takes an expert in the area that you're studying to help determine the factors and to be able to interpret them. And that's it for this video. Now, as I was developing this playlist, chapter 11, I could either have a few longer videos or more shorter videos. And I decided to go with more shorter videos to capture chapter 11. And so the next video, we'll start looking at what's called an orthogonal factor model in factor analysis. And so I hope you enjoyed this. I sure did. Please like the video and subscribe so you don't miss the next one. Thanks. Bye.